Doesn't matter whether you have your holes in it yet that are threaded. It can be before or after. All right. What we do need is to have the end glued, probably the other end glued. Remember, we have our parting line across the top. We want to have our vertical line in there, and we do that by setting it on the surface plate, taking a square, putting it up against here, transferring this line around the end. We need that center point mark for that hole. Okay? One of my face plates is right here on the bench. The other one's mounted to the lathe. Let's take a look at this one for a second. I've actually traced a base. Right? See? Good exercise.
Great exercise.
Okay? You want your base to be mounted centered like that on one of those slots. All right? That symmetry helps us. Center point is going to be center of our spindle line on the lathe. So we're going to put it on there like so. And just like we did it on the drill press, we have to clamp this area because we're referencing this surface to our faceplate. That's going to go on like so. Now what makes it easy to hold is to use our tailstock. Got a neutral. Tailstock comes up. Remember I mentioned the carriage is over here out of the way. Shift this way, Nick. Just in there.
Just wanted to start with
that. Okay. See what I've got. Right. It's not perfectly centered yet, but it's close. All right. We've got our T-nuts, we've got our bolts, we've got our nuts, we've got our hold downs. You go in there. This is kind of a three-person job if you haven't done it before. It does help to have that tailstock doing the job. Now, those hold downs, to clamp themselves, like when you're doing it on the Bridgeport, they should be parallel with the faceplate or parallel with your table. If they're angled too much, you start cutting and getting aggressive, they can come loose. If they come loose, the power of this machine breaks stuff. Aluminum's the softest metal in this configuration. It's going to damage your base somehow. Might twist it, might break it, might break our cutters. We got to get it mounted correctly. Get it where you think you want it. One of the wrenches off of our mills works for our hold downs. We've got one mill out of commission right now. That's where this wrench is from. You keep borrowing other people's wrenches, you're all wandering around looking to try and make it work. So try and just keep one. Okay, that's about where I want it. Now I have to center it up. By the way, that's seriously out of balance. For that reason, we don't run it at a high speed. Seriously out of balance, high speed means it throws that thing off, and you'll be lucky not to catch it in the chest and have it kill you. That would be a bad day. Okay. Now to get it centered, we've got our layout marks on the end. We've got our center, our lathe center that we can use. We bring that up, get it close. We're using it like a wiggler. We don't touch it. We don't touch the crosshair. We get it where we want it, and we bring our brass hammer in here. I like people moving around so they can see. I don't mind you moving up and back and so forth. I'd rather have you see now, get more of the picture now. Right? Hold downs aren't real tight. With the brass hammer, I can come around and tap that, so I can spin that and have our center crosshairs stay centered on our tailstock set. All right? That's how we're getting it. Once we have it where we want it, move that really close if we like to. And the two lines that we're looking at, I like looking right down the line, right across that point. Then I turn the piece 90 degrees and look right down the line. It tells me I'm centered. Then we can come back and we can snug up our hold down. Do that. I often like to have it in gear, and then I can put some torque on this. At this stage, it's a great spot to stop and call me over. Say, hey, Dr. Erickson, will you look at this and check it for me? Because then what I'll do is I'll take the wrench and snug it up myself. Know what that does? That shifts responsibility to me. If this really screws up and breaks, and you need another piece, say, Dr. Erickson, it's week 13. You just screwed it up because it wasn't tight enough. Like, well, I might have a spare one in the back room that we can save you with. On the other hand, you screw it up. It's like, you know where the sand is in the foundry? Right? Okay, I guess you got that one. All right, we'll snug it up. All right? Now, from there, our speeds. We run about 100 RPM. In this machine, we've got 72, we've got 98. You can run either one. We are starting with a small hole. We're going to a bigger hole, to a bigger hole, to a bigger hole, to a ring. It's that simple. The small one that we start with is going to be a center drill. That center drill just proves to you that is where we want it to be. It also gives our first drill something to follow. Okay? That helps us out the whole time. So we'll have one of these. Everything will be in this kit. It's not there yet, but it will be. Then we have a smaller drill, and we have one just like it that's longer. We're going to start with the shortest one and the skinniest one and move up. And then we're going to go to a little bit fatter, and then we'll move up. And then we're going to go a little bit fatter, and then this will go through all the way. This does a couple things for us. The physics, I know you don't want this, but the physics behind the way a lathe works, when that piece is spinning, your drill will naturally want to center on that part, on the center line of that lathe spinning. Even if you're off at an angle, because it's spinning and the drill is not, it will naturally go through center. You can't do that on a drill press. If I put this on a drill press and the table's not clean and it's angled, that drill's going to go through at an angle. If it hits a pocket in there, the drill is going to follow the pocket as if it's a guiding hole, and it'll bend. This tends to center itself. So we go step to step to step, and if the first hole's a little bit wrong, the next one centers itself. That one's a little bit off, the next one centers itself. So we get better and better.
How many?
These are all our drills.
So far.
All right, so we start off with the smaller diameter and the short, we go to long, go to this one, and we go to this one. Now this one does not quite reach all the way through. So what we have is an adapter that we can use that will help it reach all the way through. The way that works, our tailstock spindle has that Morse taper in it. It reaches far enough up on the taper it reaches almost to my thumbnail. That's how far it reaches in there. Look at the difference with my adapter. See that? That, in essence, lengthens our drill long enough to go all the way through. Now, like we do in other cases, we want our whole system to be as rigid as possible. So we start out as short as possible, drill those holes, and then only when we have to do we reach out. And this will just let us finish that hole. Once the hole is done, then we have a ream. We'll go through the first side, take it out, put this back on it, and it'll let us go through the other side. We're going to do the 100 RPM for the drilling. We're going to do the same for the ream. When we drill, we've got coolant on this lathe. In this case, we turn the switch in one direction, the motor starts, that little light goes on, and while it's running, we turn the switch in the other direction, and our coolant pump comes on. You have a reservoir down there with a milky white water-based coolant. We're going to use that while we're drilling. We don't want coolant all over the place. We got a splash guard here. Goes in, helps keep coolant off the floor. You may get coolant on the floor anywhere. Right over here, we got a mop, paper towels. All of our drilling gets done with the coolant. When we get to the ream, we're going to put paper towels down and use black cutting oil for the reaming. All right? When we get our first person over here for the ream, I'll take a break, call all of you in, show you how fast we're running the ream through, so you can see that operate. Okay? Got the ideas. All the theories now in here. You see people over here doing it, I'll be here to help you with it. Take a break, come over, see what's going on. Okay? We want to get this right. Questions? When we're done, paper towels. Clean off the bed, clean all the chips, all the crap into the bed. Sometimes your coolant will stop flowing. We need to use a squeegee type of device or some piece of small sheet metal and run all this coolant over to the back corner where it drains down to go back to the sump to get recycled. What we don't want to do is get that cutting oil in there as well. We use paper towel when we're reaming, catch that cutting oil, and we throw that away. All done. Everything's wiped down into the pan. Fridays we clean the pan. Okay. Long enough. Thank you.